Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at EDB. I will be your host today for our webinar, Overcoming Write Availability Challenges of PostgreSQL. I'm joined today by John Dalton, Senior Director of Product Management, and Bhavani Rao, Senior Product Marketing Manager. Before we get started today, I just want to go through a few housekeeping items. We want to hit the next slide. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the Q&A panel. Today's session is scheduled for 1 hour. We expect the presentation to last most of our time, and we'll allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards with any attendee whose question was not answered. Now, without further ado, I hand it over to John and Bhavani.
Great, thanks, Molly. Thanks everyone for joining us today. I just want to cover the agenda real quickly and then dive into the meat of the discussion here. So today we're going to talk about high write availability as an aspect of high availability, and then get into some of the challenges with different logical replication tools that are out in the marketplace today, talk about a particular solution that we have with EDB, talk about some of the features and benefits of that solution, some other recommended use cases we have, and then some next steps. So, and then after that, we'll have time for Q&A. So please, pop your questions in the Q&A widget there, and we'll definitely get to those later. So with that, the question is, what is write availability? And I know everyone is thinking about high availability for their databases, but to kind of open up the aperture a little bit and talk about high availability for your applications in terms of the systems you deploy, we all know that that's a critical thing that we all have to address, and sort of that umbrella concern we all have. And when we look at that deployment of high availability for our applications, we know that it's not just the application, but all components in that infrastructure that support the application that need to be highly available. And the way that we do that is we have redundant components in that infrastructure available to tolerate any failures an individual component might have. So we understand that, like, if we need to make the database more support high availability, we need to have more than one database. But that's true of all the components in that infrastructure, including the storage and the networking. So, we need to have that full stack of components available, that full stack of components redundant, so that we can have recovery from a failure. And we might need to have multiple levels of redundancy to support higher levels of availability. That's critical, and we'll talk about that as we go forward. But I think folks are familiar with the concept of unplanned downtime and how much uptime do you have in terms of the number of nines? Is it 99.9% uptime, which is 3 nines, or is it 5 nines, which is sort of the gold standard that telecoms and financial services types of applications tend to have? So that being the broad umbrella, high availability, there's a couple of areas under that come into play when we're talking about databases, because we know with databases, you can organize things well for readers or writers, but in the middle, it's a little bit different. So it really depends on the mix of transactions going to the database. So when we talk about read availability versus write availability is about having a high read to write ratio for the transactions that are executed in the database. And we can tailor our architecture to take advantage of this need for supporting our application. So for example, and we'll talk about that in a little bit in a couple of slides coming up. So, and then conversely, with write availability, it's flipped. We're talking more about applications that do a lot more writes. So that's inserts, updates, deletes, that activity that causes not only activity in the database server, but also down to storage and making sure things persist. So there's some slight tuning that we might need to do for that. And having an architecture that supports that for our application is important. So that's today's focus, is write availability, because these can be some of the more challenging designs to deploy. So let me share an example of a write availability scenario. Here's an application that's talking to a database, right? So the application is connected to M1, let's say it's an application we see in the financial services sector. So it could be a payment gateway, something that's processing a lot of very business-oriented transactions. So there's a financial or monetary aspect to these transactions. So that application, it might be handling a lot of transactions per second. So let's say it's hitting the database at a reasonable 1,000 transactions per second. And if each of those transactions is worth about $100 on average, a second of downtime becomes $100,000. So what do? We have another database available alongside it. So if there's a failure, we can go to it. And this is one classic use case of multi-master replication. So we have our second database there, getting all of the data that's updated in the first database available in the second database. So they're in sync. So if there's any error or failure below the application in terms of it connecting to the infrastructure there, it can just create a connection over to the second database. So we can basically, in connection, in terms of establishing a new connection, fail over to that second database, providing continued availability to the application, and continuing on with minimal or almost no downtime, right? So this is a key thing here, that when we think about write availability, and again, it's the impact that it could have on the business. So if we're thinking about that 1 second of downtime being $100,000 a minute, is $6 million worth of impact to the business. And when we talk about 5 nines, we're saying that's a little over 5.5 minutes a year of downtime, of an unplanned downtime. So you can quickly get to the point of understanding what's the risk to the business for downtime, what does that cost to the business, what does it cost to support infrastructure to mitigate the risk of that downtime. So you can pretty quickly get to a business case that supports that level of redundancy. And then it's like, is it 1 level of redundancy or 2 levels of redundancy? Again, it depends on your needs and your particular application, but just want to kind of set that as the context for our discussion here in terms of that need to keep your database available for an application like this. So some considerations when we're looking at replication tools, there's a lot of different things to consider, obviously. And it's not just the technology, but it's also some of the business related aspects of that technology. So for example, if you're looking at a particular replication tool, is the provider of that tool, are they grounded in Postgres? Are they coming from that expertise? Or are they coming from the perspective of, we're a replication vendor, we're the experts in replication? Or it could be, they're coming from the perspective of another database technology, and Postgres is just another thing that they connect to. So are they really, where's their expertise there? So that's one aspect. Another aspect of looking at tools is whether your license is open source or commercial. And again, it depends on your enterprise and the direction you're traveling in, what kind of tooling you can support, whether the tool is commercial and you're working with open source Postgres or both. So all of that is part of your decision process here. And alongside of that, obviously, is what sort of support will you have for your tool and your overall infrastructure, right? If you're a financial services organization and you can't really tolerate a lot of risk, going the self-support option is probably not for you. You may want to rely on a vendor that has the support available there to help you troubleshoot, diagnose, and potentially fix issues. Furthermore, how are you deploying your tool? What does your overall ecosystem, your enterprise look like for deploying these applications? Are you on premises in a private cloud? Are you only deploying into one public cloud? Or are you looking at a multi-cloud strategy that we see happening with a lot of our customers? Or, and then also, is the application operating within a single region, or does it need to operate across multiple regions? Those are really key considerations when you're looking at our tooling choices here. So now starting to move more into the technical aspects. You know, what else is in your ecosystem, right? What other database technologies, what other systems are in your enterprise infrastructure that you need to address, right? You know, how does Postgres fit into that ecosystem? From a tooling perspective, what is that architecture? Does the tool operate as a centralized, it has a centralized architecture where kind of it's like a hub and spoke or something like that? Or is it adopting more of these cloud native principles of it being a distributed computing type of architecture? When we start looking in terms of how the tool operates, what is that change capture mechanism? Is it invasive, like triggers that have to be installed in the database to follow the changes that are happening? You know, that may be appropriate, but if you're running a commercial off-the-shelf type of application on top of your database, that could violate the terms of your license agreement with that vendor. So that may not be a reasonable choice. Or is the change capture mechanism something that fits in alongside the database itself as an extension, or follows the log files and so on? And then finally, let's talk about the method of replication. Is it physical at the database, at the data file level, you know, those physical bits that are stored, or is it more at the logical level in terms of how we think about interacting with the database through SQL? As well as, how often is replication happening? Is it periodic on a scheduled basis, or is it on a continuous real-time streaming basis? So all of these things are considerations when you're looking at a particular application and supporting replication in support of write availability. So with that, I wanted to dive a little deeper into different replication methods and how that ties back to write and read availability. So for folks who are not as familiar with all the options in Postgres, we have two main things. We talk about physical and logical replication. Physical replication is exactly that. It's that binary data from the write-ahead logs that is written to storage, and it's from all schemas in the active database. And those changes, all of those changes are sent to all of the replicas byte for byte. So that it is whatever that representation on disk is sent to the other databases. And each node, since it is binary, each node has to be on the same major version of Postgres. And you know, it also has to be on the probably same version of the operating system as well, right? So because it is tied to that, it is physical. So it is tied to that machine structure. Also, want to mention that, you know, as we write to that active database, all of the changes are replicated out to the replicas as read-only. So it's in concept, it's a single master replication type of architecture there. And then finally, Postgres offers both asynchronous as well as synchronous replication. And, you know, again, it becomes that trade-off in terms of looking at the CAP theorem in terms of what's more important, consistency or latency. So, you know, you have options here to support a mix of those things. And again, this is, physical replication is really good for read availability architectures for those applications that do a lot of reads. And there's a couple of there's multiple ways of getting there. Your application might be structured in a way that can connect directly to those read-only replicas, or you might be using a tool like pgpool, which can your application connect to, and it routes to the appropriate database server for reads versus writes. So that's a great way of addressing those read availability needs. Now let's switch over and talk about logical. Obviously, if we're talking about logical, we're talking about how we think of the database from relational database terms and SQL. So it's tables, it's columns. So we have much finer grained control over how changes are replicated from the objects in the database. So we can have, you know, through the use of row level filtering, we can select specific rows to be changed and replicated over to the replicas, or it could be, you know, all of the tables in a database, or it could be a subset of the tables in a database, or in one of the schemas in the database to scale up to everything that might be in the cluster. So a lot more control over what gets replicated. And again, since we're operating at that more logical level, the database node can be on different versions of Postgres. So the replicas could be on a different major version than the master node, for example. Also important to support where physical tends to be unidirectional, logical is bidirectional. So writes to all of the nodes are supported. This is a classic multi-master replication scenario. And then finally, because we are operating at the logical level and using ANSI SQL, interoperability with other database technologies in your ecosystem is possible, right? That can be supported, and how that's supported is a different question, but that is another possibility. So again, this is talking to how logical replication is best suited for write availability. So with that, I wanted to then talk briefly about some of the challenges that we see with different logical replication tools on the market. So this isn't necessarily specifically just what's in open source PostgreSQL in the community, but also what other vendors provide in the Postgres space as well as outside. So some of the things, some of the challenges we've seen, so that our customers have experienced is, you know, that replication tool or that service has a requirement to be co-located on the same node as the PostgreSQL server. So that can introduce some conflicts in terms of resources on the machine. So that's one thing that we've seen that could be a problem. Some of the tooling has a single point of failure. You know, there's ways to address sometimes these single points of failure with other ways of structuring your architecture, but then it becomes an interesting, more expensive solution if the tooling itself isn't out of the box, you know, fault tolerant. So that's another thing to look that we've seen. May also be dependent on the vendor provided version of Postgres, like as some solutions might require additional capabilities or require specific build of Postgres with their tool. So we know we see that out there as well. And then out of the box, Postgres does support logical replication, and that's what we are using for the solution we're about to talk about. But that out of the box only supports the data changes in the database. So while very powerful, when you start thinking about the world that we're in today with SaaS applications and DevOps motions where we want to have continuous deployments, if I need to change the schema or the DDL for you know, the database that's supporting my application, I would like to have that change also as part of my push to production, right? Like I want that to be just in the flow of my DevOps motion. So that, you know, depending again what your requirements are, that can be a limitation. And then finally, you know, it can be difficult to scale the replication service to the workload of replication alongside of the database. So again, depending on the load of that the application creates for replication separate from the load that it creates on the database server, you may want to be able to segregate those replication workloads outside of the database server and be able to match it to the workload there. Because you know, over resourcing, it, you know, can, while it gives you some risk mitigation, it can also be expensive if you never really tap into it. So there's an interesting play here when we talk about scalability, and for that I think we should talk a little bit more about in terms of scaling. and how that impacts availability, right? So I think everyone knows and everyone's experienced vertical scalability. Obviously, this is where we have a given node, certain amount of resource that we have available to us, whether if it's a compute node, so many CPUs, cores are available. If we are running out of headroom, we might go up to the next size of node in order to give ourselves a little more headroom for being able to support our workloads. That's great, but like all physical resources, at some point you run out. So vertical scalability is basically going to be always limited. And then, so the other approach obviously is horizontal scalability. And what we see in, again, more of the cloud native motion, a distributed computing architecture whereby you can choose the right size physical node to run your service on, and then have multiple redundant nodes managed so that if any of them fail, you can have continued service availability by moving a workload to another active node. So a way to help manage the size, manage your workloads to the compute nodes themselves, and then also scale out as necessary. And then again, it being able to be independent of the node of the database server. So you want to be able to match those workloads as best as possible. So those are all of the challenges or considerations to think about when you're approaching your your need to support write availability for your application. So everybody's everybody's application that needs to support is always going to be slightly different. So it's important to keep these considerations in mind when you're looking for a particular solution to implement. And with that, I wanted to switch gears and talk about a solution we have with EDB. And this is EDB Replicate. So it's a new logical replication tool or product from EDB. And I always like to follow the Simon Sinek start with why conversation. Why is this important? And it's important because it protects data availability for mission critical applications in order to mitigate that business risk, right? If I can't run my application, I'm not making business happen, right? That's a critical thing. Going back to that earlier example, if we're down for a minute, that's $6 million of revenue the business is not going to see. So that right there puts a fine point on why we want to mitigate that risk, right? We want to keep the business operating. How we do this? We do this because we built it on Kafka to help eliminate all those single points of failure and provide that high write availability that applications need. And what we've done is we've provided a scalable, fault-tolerant data replication capability for single and multi-master replication use cases. And write availability is one of those, right? And we'll talk about a couple others later in the session here. So with that, I wanted to then dive in a little bit more detail in terms of how EDB Replicate works. So as an example here, I'm showing a picture, an architecture, a simplified architecture of how you might deploy these components, right? So again, thinking about this cloud motion where you have multiple availability zones available. Let's say we want to have 2 levels of redundancy so that if we encounter a failure, we still maintain high availability because we have another redundant component available. So that's how we get to 3 copies of the components there. And in this diagram, we're showing the active application running in zone 2. So traffic is routed to this zone from the internet. The application is running there. The database in zone 2 is the active database taking writes. And then the EDB Replicate service is behind the database, making sure things are replicated to the other databases. So in the database itself, we identify set of tables that we want to watch for changes that need to be replicated to the other copies of that database that are available. The logical decoding in Postgres is used to identify those SQL level changes. So we'll see, column A changed from an X to a Y, and table Z that gets put on that is then transmitted through Kafka to then be processed and applied to the other databases. Again, since EDB Replicate is following more of a cloud native or distributed computing motion, they're cluster aware, so they're aware of each other. If one of the Replicate servers does encounter a failure, one of the other ones can take over and manage the workload and make sure everything remains in sync. So again, the service itself is highly available or supports a bit high availability. And again, being built on Kafka as a fault tolerant solution. So again, we think about high availability, we have to think about failures at each tier in the application, each tier in the architecture there. So that's, when we're talking about the replication tier, we've got high availability deployed there. If a database encounters a failure, obviously that requires the application to switch to another, there's different strategies you can deploy, whether the application switches to use another database or whether you switch to another availability zone. All of those choices are part of what you have to decide when you're building out your architecture. But in any event, if a database fails, it'll resume from the last sync point when it recovers and continue. And in the case of where there's any conflicts, we do support row level update conflicts, so the last update will be applied. So we are maintaining consistency across all of those databases as well. And lastly, just want to mention we're using an anti-affinity deployment pattern, which again, this is where we can scale out replicate. It's not co-located on the database node. So that's just a final point there. Now, let's take a moment and just look inside those green boxes that are, say, EDB Replicate, just to see how that software architecture is put together. For folks who are familiar with Kafka, you're talking using the Kafka broker to talk to a particular topic. A topic is one of these things that you can subscribe or publish to. So when we talk about that in terms of how replication works, we can create a topic that's related to a set of tables we want to watch for changes in a database and replicate to the other databases that are participating in this replication network. One of the things that's really cool with Replicate is we can have multiple publications out of the database, so multiple different sets of tables can be replicated across to other to the replica databases. Those can be tables in the same schema or in other schemas within the same database service. So there's a lot of flexibility in how that gets configured. Obviously, building against Kafka, that development pattern of having a consumer and a producer are to basically provide topics with changes and then pull changes out of the topic. So effectively, from logical decoding, the producer is populating the Kafka topic with changes. The consumer on the other end is pulling those changes out and applying them to the database. The changes themselves, when they're put into the topic and pulled out, we're using Avro as the schema management capability. Avro is very compact, I would say, is the easiest way to think of that. And that can help manage what we put on the wire and help to reduce latency between databases as well. So a very important component of keeping this as performant as possible. Also with Kafka, there's some additional compression options that can be used. So like gzip and snappy can be configured on, so it can, can apply additional compression. So between compression and a compact data serialization capability, we try to keep things as minimal as possible. And I think that really talks to everything here. And obviously Kafka is itself fault tolerant. So, finally, just to mention that Kafka is bundled with the EDB Replicate node today. So that's a little bit about the architecture. And now I just want to take a few minutes to cover any of the questions we have on Kafka. I mean, things that, if you're not familiar with Kafka already, this is a fault tolerant open source stream processing platform. There's a lot of case studies out there. It's well known. It's become the de facto infrastructure standard in enterprises for capturing and publishing events. And that can be not just for databases, but for any kind of logs that systems put out, or web logs and so on, that can be used to kind of capture all that, what some have called the digital exhaust of an enterprise. And that can be used for machine learning and to continue intelligence to understand how the infrastructure might be performing and be able to get ahead of problems, right? One of the important things that I should mention is that Kafka is being used in enterprises, and our customers are telling us that this is the way that they're integrating their enterprise processes and workflows through Kafka. They're running their Kafka infrastructure to do that. So that's really become an important way to have that connective backbone across the enterprise. So, plugging into Kafka is becoming more and more an important thing. And then, as we said, it's a distributed architecture that provides fault tolerance. So all very important components of what goes into this solution. Just to summarize, I'm going to go through some of the features and benefits. I think we've touched on a whole bunch of these already in terms of the horizontal scalability, matching the workload to the resources available, it being distributed, obviously not competing for resource that the database server has, not competing for those same resources. Being able to work with both Postgres and PostgreSQL as well as EDB Postgres Advanced Server. A lot of that helps support your need to avoid vendor lock-in by using the community PostgreSQL. And then, of course, because it's logical, you can support different major versions of Postgres, or support Postgres on different operating systems or clouds. It's a way to be able to work across those, but also it can provide you with the ability to do rolling upgrades so that you have minimal downtime, which is probably also important if you're focused on write availability and not having much downtime in your infrastructure. Moving on to fault tolerance and performance, we talked a bit about that. There's no single point of failure. There's not a need to retain the WAL files if replication fails. Bidirectional replication, or being able to support different multi-master architectures is important. Allows us to have complex architectures, and we manage row-level conflicts to maintain consistency. Consistency is very important, obviously. We did talk about the end-to-end data compression with encryption. So again, keeping data latency between nodes as low as possible. And from a usability perspective, we also can take advantage of some of Kafka's capabilities to, like for snapshot purposes, being able to use that to seed a new database. So if a node goes down, we can bring it back up using the information we have in Kafka. So it doesn't have to impact any of the operating databases to bring up one that might have failed. We did talk briefly about row level filters and it being the benefit of being able to manage what gets replicated. We did mention multiple publications per database. So again, be very flexible in terms of the way, or flexible or be very fine-grained in the way that you approach replication. And then also we have some alerting and monitoring capability built in, so it can help simplify maintenance of large clusters. Some additional capabilities to touch on that just to make sure we covered everything. So cascading replication was something we didn't really talk about, but again, Postgres logical replication of the box does support that, and we support that with EDB Replicate. What this means is a consumer in a replication network can also be a producer in another replication network. So it can be, so you can cascade changes down through different replication networks or clusters, depending on how you talk to those groupings. We also are offering a new CLI experience called the EDB CLI. It's going to become our unified CLI to support all of our tools and products across our portfolio. It's going to come, its first release will be with EDB Replicate, and this unified experience is also really meant to help with usability of our products and be a lot like what we see with other applications out there, like Docker or AWS or Git, like that kind of more modern CLI experience that folks are finding to be a lot more productive. From an environmental perspective, a lot of security things that we address and support. So in terms of authentication and access control, to make sure that the right roles are connecting into the right parts of the database and the Kafka infrastructure. So it's all controlled from an access perspective. We support PostgreSQL and EDB Advanced Server 9.6 and above. Obviously 13 is now coming out, so we will be adding support. So it's just a timing thing at this point. And then it's available on RHEL 7 and 8 on the Intel chipset with, and those are available as RPMs. And we did mention Kafka with gzip and snappy compression options. And so that really covers a lot of what the solution offers. One thing I did want to talk about, a couple other recommended use cases that we have. One that we see our customers faced with is we call it Geo-Distributed, a Geo-Distributed multi-master replication scenario. In this situation, looking at this simplified picture, we have an application that's operating in a given region, or actually it's operating in multiple regions. The challenge is to provide the best experience for the users of the application in that region. And the way to do that is by having a database in that region close to the application, so it reduces that latency in the experience that the end users of the application have. So the way to think about this is in that given region, I'm interacting as a user with that application. All of the updates or the writes for that region are happening into that database. So a way to think of this from a database perspective is that it's naturally sharded on a regional databases. And then that data is replicated to the other nodes such that all regions have the complete data set available to them for operational purposes, right? And a great example of this are like logistics applications. So for example, if it's an order management application, I'm sitting in North America. So if I place an order in North America and the item needs to come from Europe or somewhere in the Asia Pacific region, then that information can be made available to the application in those areas so that all of that coordination can happen as appropriate. So that's one example of a geo-distributed application and this multi-master replication scenario. So that's one we see. Again, that's a way of accomplishing that use case. And then finally, a data distribution use case. This is more of a classic single master replication scenario where I have some shared reference data, or some organizations call it master data or golden data. This information is managed through a system of record or application of record, and then that data is then shared with other applications. An example of that might be, I have a product catalog that lists all the different products I have. Stores have inventories of those items in the product catalog. So making sure that everyone has the same product catalog information is important so that reporting back up like inventory levels is possible. So in this scenario, the application of record is publishing data, this common reference data, out to those other replicas where the applications use it in a read-only manner for their needs. So this provides accurate and consistent shared reference data across the enterprise applications that need it. All right, so with that, I just wanted to then have a word from our sponsor, EDB, and hand this over to Bhavani.
Thank you very much, John. This is Bhavani Rao. I'm a product marketing manager here at EDB. And for those of you who may have been reading the news, on September 30th, the EDB just took a big step forward. So this slide has been updated to reflect that, and I'm going to talk about it in the next couple of slides. But we have made a big effort to supercharge PostgreSQL by acquiring Second Quadrant on September 30th. So we have now a huge base of customers, about 5,000 customers. We've added significantly to our employee counts with about 500 employees. And we've consistently provided as a vehicle for not only contributing to Postgres by being a major contributor as EDB, but also we've benefited from the folks that have come as part of the acquisition as well, who are many of whom are community leaders onto themselves. So we have a global presence, and more importantly, one of the things that I'd like to highlight is that we have been featured in the Gartner Magic Quadrant for operational databases for the last 7 years running consistently. Next slide, please. So I just want to hit this point one more time, is that one of the benefits of acquiring Second Quadrant is that we have access to a talent pool that now puts us in a position where we're the largest dedicated provider of PostgreSQL products and solutions, in addition to the fact that we have now a knowledge base of folks who have had a multi-year commitment contributions to the PostgreSQL community. So we're basically, this is an acquisition that was in some ways has been received very warmly by analysts and many of our customers, because we're able to scale up to meet larger customers, as well as to be able to address aspects of the market in terms of functionalities that we were not able to address in the past. Next slide, please. So going from here, what I want to say is that we want to wrap up the discussion and then have one more slide talking about, our next steps. We want to bring it back to our discussion on replication, saying that replication mitigates business risk by providing data availability, particularly for those mission critical applications. And this is a solution. EDB Replicate is designed to be able to help customers who are trying to migrate to the cloud and be able to provide responsive, low latency applications that are distributed, that have to respond to customers worldwide. And it builds upon logical replication that's natively provided with PostgreSQL by adding enterprise features. So you add additional features in terms of the default tolerance, the ability to be able to scale, etc. So last slide, please. So at this point, we're going to jump into Q&A. But before we do that, one of the big important things I want to tell you about is that EDB Replicate, we're hoping to have it out for GA next week, but for purposes of being a little conservative, we put down late October for GA. And if you're interested, we'd like to invite you to go ahead and contact our sales folks and get started on trying to evaluate the solution for a particular fit in your respective use cases. So at this point, I'm going to open it up to Q&A. I'm going to let Molly go ahead and run through the Q&A and see who wants to take the questions.
Yeah, so we got a ton of really great questions today. We'll jump right in. We'll answer as many as we can. So the first one we'll start with is, what is the best practice for high availability for critical business systems?
What is best practice? That is a great question, and I think part of it depends on your particular business. But for critical business systems, obviously having multiple levels of redundancy available is a best practice, right? Having those multiple components so that you can have failover possible, have it automated, have this as much in place so that you can minimize downtime. I think to get into what it means for your particular, for your particular enterprise, your particular application, I would say the best thing to do is to contact us, because we have a lot of experience with our professional services team in deploying these in very different environments. So that's, I think, a good next step for you if you wanted to learn more about how it applies in your environment.
Great. Okay. Another question that we had come in was, does EDB Replicate support bidirectional replication?
I'll take that. I think we mentioned it a couple of times that, yeah, definitely EDB Replicate supports bidirectional replication, and this allows for being able to create complex architectures. And that means that you can have some scenarios where you can use both single master replication as well as multi-master replication across different clusters. You want to add anything to that, John?
Yeah, I think that pretty much covers it. Yeah, you can have in the different, we'll call them replication networks or clusters, you can identify on what we're talking about, a Kafka topic, or what we're talking about, a publication. It can be, your database can subscribe to it as a read-only database, or it can subscribe as a publisher as well. So you can have a very mixed set of databases participating in that cluster. So you can go fully multi-master replication, or you can go the other direction and be just single master replication. So it's unidirectional out to the replicas, or you can have some mix in the middle there.
Okay. All right. The next question we'll address is, are there any restrictions on bulk loads, or is this only for OLTP load transactions?
Yeah, that's a good question. We have, there are certain things that obviously happen when you're trying to get a system up and running, or you might have to do some maintenance on things while the system's in operation. And there are ways of managing that in terms of how you can load data without having all of that data be replicated to the other nodes. There's definitely there's some options that you can set so you can do that. It's similar to what we see in some other replication tools for addressing that.
Okay. Another question that we had was, is it possible to verify a logical replica, or is this limited to physical replicas?
We do also provide a data validation tool as part of the product. so you can confirm that everything is consistent across all of your replicas? That's a good question.
Yeah, it's included as part of the offering.
Yep.
Okay. Another question that we had come in was, have you seen EDB replication used in bridge to cloud patterns? For example, on-premise PostgreSQL database replicates to AWS Aurora PostgreSQL instance.
That's an interesting question. We're focused on deployments of the open source PostgreSQL. So we would be able, in a scenario where we have something on premise with Postgres, and you have something in, say, using AWS RDS PostgreSQL, that's a scenario that we would support. We get in, there's certain challenges in AWS Aurora because the backend isn't necessarily Postgres out of the community. So that's more of a supportability question than a technology question, I guess is the way to leave it.
If I would add to it that if you have a self-supported PostgreSQL running on AWS EC2, then you won't have the same. You shouldn't have any issues. We should be able to support that.
Mm-hmm.
Okay, I think we have time for one more question. We got so many today. I won't overwhelm anyone. So the last question we'll tackle today is, what happens if there's a conflict? For example, the same rows updated on two databases. How does it solve conflict resolution?
Oh, that's a good question. So today we support row level update conflicts. And the way in which we manage that is it follows the last update wins kind of rule. So when that happens, we have a option to follow we know that the timestamps are on the transaction, so we can identify which was the latest transaction to occur against that row. So that's how that's handled today. In the future, we're looking to support COM level update conflicts, and that's something that's on the roadmap as well.
All right, great. So that is all the time we have for today for questions. I apologize for all of those that we were unable to get to today live. Thank you for joining us for the webinar. Again, we will be sharing this recording along with the slides with you as soon as possible. And I hope you have a great rest of your day. Thank you, guys.